because we are asked to determine the reactions at A and B. Alright, but before we can be able to do this, let's first of all change this uniformly distributed load to a point load. You can see that we have 20 kilonewton per meter. So it's spanning from this point to this point, this 4 meters. So I used to say that for every 1 meter you have 20 kilonewton. For every 1 meter you have 20 kilonewton. So we have to convert it to a point load. That is the first thing we need to do. We have to redraw the free body diagram for this. So let's go. So at this point, this 20 kilonewton per meter, if converted to a point load, the resultant will act at the center of this span. At the center means we have 20 kilonewton per meter multiplied by the span is what? 4 meter multiplied by 4. So it will act at the centroid of this span. So here will be 2 meter, here will be what? 2 meter. Alright, this 20 kilonewton per meter is now acting at the center of this span. When converted to a point load, becomes 80 kilonewton because it will use this 20 multiplied by this 4 to give us 80. It will be acting at the center of this span. So here will be midway, here will be midway. So having done this, now we can now proceed. Let us assume that this system is in equilibrium. Since our beam is not turning, it means that the sum of the upward force will be equal to the sum of the downward force. So let's go. So let's say the upward force A plus B is equals to downward force. This 20 kilonewton meter is not a force, it's a moment, so we will not consider it. So we'll come to this point. Here is 10 and what? 80. So we have A plus B equals 90 kilonewton. So let's call this equation 1. Let's leave this relationship. The next thing for us to do is to take a reference point, take a moment about a point. Let's take a reference point. Let's take moment about point A. So if we sum moment about A, will be what? Multiply sum of moment about any point is equals to 0. So if we take moment about point A, it means we cannot say that. We can start making reference to this point. You can start from this point or from this point. Let me start from this point. So here, this is not a force, it's moment. So it's acting clockwise. I'm taking clockwise positive, anti-clockwise negative. So I'll have 25. We'll go to the next force. 10 acting downward is acting clockwise. So I'll say plus 10 multiplied by the distance from my reference point, 2 and 3, which is what? 5. Then here is negative anti-clockwise B multiplied by the distance from my reference point, which is what? 8. Then the next force is this. It's clockwise positive. It becomes 80 multiplied by the distance from my reference point, 2, that is 5, that is 10. So all these forces will amount to summation of all this equals to what? 0. So having done this, we have 25 plus 10 times 5 is 50 minus 8b plus 80 times 10 is 800, all equals to what? 0. So here we are solving for b, you can say minus 8b is equals to, let's say here will be minus 800 minus 50 minus 25. So So let's check out all this. This 8 minus 875. So because we're solving for b will not be, this negative will go 875 over 8. This is equals to this divided by this. (109.34 kilonewton). So I've gotten the value for B. So let's get the value for A. Remember that A plus B is equals to 90. So it means that B is equals to what? 109.3 kilonewton. Then A is what? What becomes A? A will now becomes A is equals to 90. This B will go over to this other side. And what is the value of B? 109.34 kilonewton. Please, this is 434 kilonewton. So this will eventually give us a negative value of what? 19.34 kilonewton.